Okay, so this is the chapter 2 red problems from Resnick Halliday 7th edition. I'm only going to do the red problems. In a 100-meter race, Maggie and Judy crossed the finish line in a dead heat, both taking 10.2 seconds. Accelerating uniformly, Maggie took 2 seconds and Judy 3 seconds to obtain maximum speed, which they maintained for the rest of the race. What was the acceleration of each sprinter? What were their respective maximum speeds, and which sprinter was ahead at 6-second mark and by how much? So I have drawn the velocity time diagram over here on the right, and you can see that red line belongs to Maggie and blue line belongs to Judy, and you can see that Judy has taken a longer time to accelerate. So we know that Tm is equal to 2 seconds, and we also know that Tj is equal to 3 seconds, and we know that the total distance that they have covered, let us call it d, is equal to 100 meters. And let us say that the acceleration of Maggie is am, of Judy is aj, and let us try to find out what is the relationship between these two runners at any time t greater than Tj, which is also greater than Tm, right? So we know that if I take any time t, the distance covered by Maggie and Judy would simply be the area under these graphs, and these graphs are simply trapeziums, right? So we know that dm, distance covered by Maggie in t seconds, is simply the area of this trapezium. So it turns out to be half times sum of parallel sides. So sum of parallel sides is this above side is t minus tm, right? So it's t minus tm plus t, so becomes 2t minus tm. And what is the height of this graph? The height of this trapezium is simply am times tm, right? So we know that the height of the graph is am times tm, where we can say that the speed of Maggie Vm is actually am tm. This is the maximum speed obtained by her, and maximum speed obtained by Judy is simply aj tj, right? Now we know that this is going to be the distance of Maggie, and what would be the distance of Judy? Distance of Judy would be, by the same logic, the area of the parallelogram, area of the trapezium under the blue curve, which is going to be half times 2t minus tj times aj tj, right? So far what we have done is we have found out the distances covered by Maggie and Judy at any point t seconds. But what happens when the race finishes, right? They have also given us that the race finishes at 10.2 seconds. So we can put time t is equal to 10.2 seconds. In that case, dm is simply 100 meters, right? So dm is 100 meters because the entire race was of 100 meters, and so is dj, that is also equal to 100 meters. So we know that we can find am and aj by simply substituting dm as 100 and time as 10.2 seconds, t as 10.2 seconds, tm is already given to you as 2 seconds, right? So let us find what is going to be am. Am is going to be simply 2 times dm divided by 2t minus Tm times Tm. And if we substitute the value of dm, which is 100, t as 10.2 and tm as 2 seconds, we will find the value of am. It comes out to be 5.43 meters per second square, correct to 3 significant figures. Similarly, if we put the values of aj, it's going to be 2 times dj divided by 2t minus tj times tj, and if we put dj as 100, t as 10.2 seconds and tj as 3 seconds, we get aj as 3.83 meters per second. Now we can also find what were their maximum speeds. We already know what is Vm. Vm is AMTM. So Vm will be actually equal to 10.7 meters per second, and we get Vj equal to 11.5 meters per second. And as for the final part of this question, which sprinter is ahead at 6 second mark and by how much? All we have to do is we have to simply find what is dm and dj at t is equal to 6. So we get dm equals to 54.3 meters and dj equal to 51.7 meters. So we see that Maggie is ahead of Judy by around more than 2 meters something, right? We can simply find out what dm minus dj is going to be, and this problem is done. Thank you for watching.